Adding, subtracting rational expressions. So if I want to add these fractions, we first got to make sure we have a common denominator. So what we're looking, do we have a common denominator? Yes. Actually, what's kind of interesting, the only problems we're actually going to do, if you look at all three of these, they have common denominators. So basically, we're only going to do ones that have common denominators, so it's going to be a little bit easier. Anywho, since they have the same denominator, all you do is you add the tops. So you basically end up with x squared plus 3x over 4x. And that might look done, but it's not, because the top can factor. I could pull a GCF on the top of x out. That leaves me x plus 3. When I pull an x out of this, x times x is x squared, x times 3 is 3x. The 4x is still on the bottom. Now what's the benefit of that? Well, what you should notice here is those x's disappear now. They can cancel. So your answer is x plus 3 over 4. That's my answer. Now, number 2. If I want to subtract these, well, the bases are the same. So basically, this is what happens on top. You add the first piece minus the second piece. And the bottom is just x minus 3. So we basically subtracted the tops. Now let's do the tops. What do you get? When you minus this, it looks like you get x squared, and 2 minus 11 looks like negative 9. And you might think that might be done, but the top can factor. It's called a difference of squares. What you got here is x squared minus 3 squared. It's called a difference of squares. And when you do that, you get x plus 3, x minus 3. So x plus 3, x minus 3. And the bottom, the x minus 3 is still there. Now what's the benefit of that? Well, obviously, hopefully you can see this. Bam, bam. Those cancel. Because anything over self's 1. 1 times this is x minus 3. X plus 3, sorry. So when that's gone, you just have left is x plus 3. There it is. The last problem. Number 3. We have a common denominator. We're good. So what we do is we take the tops, x squared plus 5x, and you subtract. And on bottom, you have simply that, since it's the same on both denominators. Now, when we subtract the tops, here's where some of you are going to mess up. You need to change this minus to adding the opposite of both those. So basically, here's what we get on top. We get x squared plus 5x. That becomes a negative 3x. And that becomes a negative 15. And the bottom stays the same. We can actually factor that. We're going to do that in a second here. So the top, when we simplify it, looks like we get a x squared. This plus this gives us 2x minus 15 over x squared minus 9. Now, all that, well, let's factor the top. The top can maybe factor. There's negative 15 on top, 2 on bottom. What I see here is a 5 and a negative 3. Okay. So the top is x plus 5, x minus 3. And the bottom is x squared minus 9. X squared minus 9, as you can tell right here, same problem, but is going to be x minus 3, x plus 3. It's called a difference of squares. And after all that work, what you're going to notice here, these cancel, leaving you x plus 5 over x plus 3. Don't try to cancel the x's. You cannot. You cannot cancel when there's a plus in between. So that simply is your answer right there.